Hey everyone, welcome back to MindSpark. Science Now. Today we're tackling a massive question. Is Amazon's Project Kuiper about to change global internet connectivity? From remote clinics in Kenya to Alaskan fishing boats, the promise is broadband from orbit with fiber-like latency. But can Jeff Bezos' team really pull it off? And at what cost? Let's dig in. Project Kuiper is Amazon's $10 billion plan to launch 3,236 low Earth orbit satellites sitting about 600 kilometers above us. At that altitude, round-trip latency is roughly 30 to 40 milliseconds, comparable to a good 4G mobile link. The Constellation started small. 2 prototype satellites, CuperSat-1 and CuperSat-2, went up late last year. Fast forward to today, and Amazon has 54 production satellites in orbit after 2 Atlas V launches this spring, just 2% of the total fleet. But enough for early network tests. Under FCC rules, Amazon must have 1,616 satellites operational by the 30th of July 2026, or risk losing spectrum rights. That means 2 heavy lift launches every month for the next 18 months. No small feat when you're relying on 3 brand new rockets: ULA's Vulcan, Europe's Ariane 6, and Blue Origin's New Glenn. Now, if this sounds like déjà vu, that's because SpaceX's Starlink already blankets the planet with over 7,000 satellites and 6 million subscribers. UK-based OneWeb has full global coverage for enterprise customers. So what makes Kuiper different? First, Oz integration. Every Kuiper satellite is an on-ramp to Amazon Web Services. Imagine an IoT sensor in the Amazon rainforest sending data straight into an S3 bucket. No ground fiber needed. Second, price. Amazon's standard 11-inch phased array antenna costs under $400 to build. It's about 30% cheaper than the current Starlink dish. There's also a backpack-friendly 7-inch terminal aimed at NGOs and disaster response teams, plus a gigabit-class 19 by 30-inch panel for enterprise backhaul. Third, optical inter-satellite links. Kuiper's satellites talk to each other with laser links pushing 100 gigabits per second, creating a resilient mesh that can route traffic halfway around the globe without touching a ground station. That's huge for secure government and maritime users. Amazon isn't planning to go it alone. They've signed backhaul deals with Vodafone and Vodacom to extend 4G and 5G across Africa and parts of Europe. In the United States, Verizon will hang Kuiper antennas on rural cell towers to fill dead zones. Picture this: a field clinic outside Eldoret, Kenya, transmitting X-ray images to Nairobi radiologists in real time. No buffering. No 48-hour bus ride with a USB stick. Or a fleet of fishing vessels in the Bering Sea, streaming catch data straight to processors on shore. Those partnerships push Kuiper toward being a network of networks backbone rather than a retail internet service provider. Though Amazon can certainly sell consumer service through its own Prime ecosystem if it chooses. Time to pump the brakes. There are 3 looming challenges. First, launch schedule risk. Atlas V is reliable but nearly retired. Vulcan and Ariane 6 are still in their shakedown cruises, and New Glenn hasn't flown at all. One major failure could snowball into missed FCC deadlines. Second, regulation and spectrum. Astronomers worry about brighter skies, and rival operators worry about Ka-band interference. Every new mega-constellation makes space traffic management that much harder. Third, environmental footprint. A recent study found that low-orbit broadband can emit 6 to 8 times more carbon dioxide per subscriber than land networks when you factor in rocket launches and satellite manufacturing. Add orbital debris risk, and suddenly Internet for All isn't a clear win for the planet. So, will Kuiper change global connectivity? My take? We're moving toward a pluralistic orbital ecosystem. Starlink, Kuiper, OneWeb, maybe Telesat Lightspeed, each with different strengths. Kuiper's ODES tie-in could make it the go-to backbone for enterprise and telco partners. While Starlink dominates direct-to-consumer, if Amazon nails its launch cadence, we'll see beta customers online by year-end and perhaps full retail rollout in 2026. If not, Starlink widens its lead and regulators start wondering whether we really need another 3,000 satellites. Cluttering low Earth orbit. Either way, by this time next year we'll have hundreds more Kuiper satellites overhead and a front row seat to the most expensive game of space chess ever played. That's our show. Links to every stat and study we mentioned are in the episode notes. If you learned something new, hit follow, leave a review, and share the episode with a friend who still thinks dial-up is a vibe. This is MindSpark. Science now. Stay curious and stay connected.